Welcome back. We are talking about water and wastewater engineering concepts. In this, we are talking about the population forecasting. This video will take up an illustrative example to illustrate how to calculate the population at the end of a design period based on the previous data. So we have seen different methods of population projection: arithmetic increase, geometric increase, and incremental increase, graphical extension. In this video, we'll take an example and illustrate all the first four methods of the population projection. For that, we'll consider the population from 1931 to 1991. So starting from 12,000 population to 74,100. So for this, we have to calculate the population in 2011. That means this is 1991 is the last decade we have. 2011 we require, the difference is around 20 years. And 20 years, what decade is 20 years. So n value is equal to 2. To calculate this, first of all, we will make a table. We take increase of population per decade and percentage increase per decade, incremental increase. So all these values we are going to put in the same table, so that we'll save time to understand three different methods in one particular example. So in the third column, increase per decade, we'll consider the population data and take the increase. 16,500 minus 12,000, 4,500. Similarly, 68,000 minus 57,500, it is 10,500. 74,100 minus 68,000, it comes out to be 6,100. So like this, we take the increase per decade, and then we'll make a total here, and then we'll make an average. How many entries? 1, 2, 3, 4, 5, and 6. So divided by 6 will comes to be around 10,350. This will be the average increase of population per decade. And then in the fourth column, we will make percentage increase. 4,000 increase, 4,500 is increase for a period of population of 12,000. So 37.50. Similarly, 10,300 per 16,500 population, 62.4. Like this, we are calculating the increase, percentage increase per decade. And total percentage increase is around 220.35. And then average increase, how many? 1, 2, 3, 4, 5, 6. So this will give you 36.76. This is a arithmetic average of percentage increase per decade. Then we'll also see an incremental increase. What is the meaning of incremental increase? Here in the third column, if you see, first increase is 4,500, then increase is 10,300. There is a positive growth from 4,500 to 10,300. Difference is 5,800 we are writing here. Similarly, 14,700 to 16,000. It's a positive increase. That value we are writing here. 16,000 to 10,500 increase. So this is not an increase. This is a decrement. How much is decrement here? 5,500 is a decrement, negative value. So all positives and negatives increments in the decades we are writing here in the last column. And then we are taking the net value of the total, net positive and net negative, 1600. How many entries? 1, 2, 3, 4, 5. So divide by 5, 320. So once we have all this data, the tabulation is ready. Now we are going for the calculation. So arithmetic increase method, we have the formula Pn is equal to P naught plus N into I. So P naught is the last decade population, 74,100. We are writing here. And N is the number of decades for which population is required. So two decades, 2 multiplied by Average increase per decade 10,350. Put down this value 94,800. So this is the arithmetic increase method. Now incremental increase method, we have the formula P naught plus n into I plus n into n plus 1 by 2 into R. So P naught is the last decade population 74,100. N into I already we have calculated 2 decades and the average increase per decade 10,350. And what is n into n plus 1 by 2 into R? N again the number of decades, right? R is the net increase, net incremental increase. All positives and all negatives were totaled and then we are taking average. That comes out to be 320. You can see here, this is the 320. This is value we are writing as capital R here. That we are substituting here and then comes out to be 95,760. Then third method, geometric increase method. So here, this method, we need to calculate IG. IG is nothing but geometric growth rate. There are two methods, arithmetic average method and geometric average method to compute this IG. Arithmetic average method means simply take here, see this is the percentage increases we have calculated and then we made it total and then take an average. This is arithmetic average. The summation of all the decade percentage increases, then total divided by number of entries is going to give you the geometric increase, the arithmetic average of geometric increase method comes out 36.76. Now substitute here in the formula. P n is equal to P naught into 1 plus Ig by 100 whole to the power of n. 74,100 into 1 plus Ig, 36.76 by 100 whole to the power of n. N is equal to 2 here. So 1,38,590. And geometric average method, this average value of all the percentages we should calculate in the geometric average method. So I1 multiplied by I2 multiplied by I3, etc. up to I6, you have to multiply and whole to the power of 1 by n numbers. So our total number is 6, so 1 by 6. So it comes out to be 30.54. This is the geometric average. You substitute in this formula 1 plus 30.54 by 100 whole to the power of 2. This 2 is basically number of decades. This is based on number of entries which are considered for calculating the average 1 by. It is 1,26,272. So now the other method is the graphical extension method. As I said, graphical extension method is simply nothing but drawing a plot between time on x-axis and population on y-axis, and then developing a plot for that. So you can see here, these points are now there, 31, 34, 31 to 1991, population is drawn and then the plot is made. And then this is extended beyond 1991 and up to 2011 or wherever you want. We want the population in 2011. So the population is slightly above 80,000. So approximately, as per this scale, it comes out to around 85,000. So this is how we simply draw a plot and extend it for the period where you desire the population. So now we'll make a comparison of the population given by all these 4 methods: arithmetic increase, geometric increase, incremental increase, graphical extension. So now what you see here, graphical extension is giving you a relatively smaller value compared to this. So it seems that the graphical extension is only simple extension of the current trend. So here, this trend may not be like this. Sometimes it may go like this also. Sometimes this may go below the projected line also. So we don't know that projection. So that's why we are taking the help of this mathematical principles. Graphical extension, most of the time it will give you under values. And arithmetic increase also is going to give you relatively lesser value compared to the actual values. But incremental increase, if you see the extra value, whatever you have got beyond the arithmetic increase method, is nothing but the second term in the equation. That is net increase, net incremental increase value we are considering, because there will be some positive increases, there will be some negative increases here during the decades of population. So that's why we are adding that. That gives a more logistic value. As usual, the geometrical increase value is going to give you the higher predictions in the population. So this is how we try to understand the population growth predicted by these four methods. Okay, so usually these four methods are regularly used to calculate this population for any water supply projects, and very simple methods to be used. Thank you.